In this video, we are going to determine the expected price in a first price sealed bid auction. Again, we start with looking at the pricing rule. And remember, in a first price sealed bid auction, the price is just equal to the lowest bid. What do bids look like in equilibrium? Well, if we know that costs are uniformly distributed between 0 and 1, then suppliers should bid 1 plus n times their costs divided by n. And then, to determine the expected price, we also need the relative likelihood of the lowest cost of n supplier. And let us start by denoting the likelihood that the lowest cost are x by f1 of x. The expected price in a first price auction is the bid that the winner makes, so the one who has the lowest costs, times the relative likelihood that the winner has costs of x, or put differently, that the lowest cost realization is x. From here to here, what we do is we use the identity that we already have derived the equilibrium bidding strategy in a first price auction and just plug in for beta fp of x this expression. And as you can see, we don't change anything here. What we now do in a second step is we split up this integral here, take this part and take that part, both times multiplied by f1 of x. Now we want to simplify this expression, or actually we want to start with this expression, and we do so by just taking the integral of f1 of x, and the integral is just capital f1 of x. And now we apply integration by parts to this second expression. From the videos that are already uploaded for the second price auction, we very much know how to do the integration by parts, and you can easily check that if you integrate this by parts, you will end up with getting this. Next, we need to plug in the upper and the lower limit for x. What we get is, if we plug in 1 for x, we get that this expression f of 1 is equal to 1, because 1 is the highest possible realization, meaning the probability that the lowest cost are smaller than 1, this is just 1. If we plug in 0, this expression here is 0. And now, so that's this here is 1 divided by n. Now we have a look at this second term. Again, we plug in 1. If we plug in 1, here is a 1, here is a 1, meaning we get n minus 1 divided by n, what is exactly what's written down here. And if we plug in the lower limit, then this expression here is 0, and that's it. What we also do is we take n minus 1 divided by n out of the integral and just write it in front of it. In our next step, we add those two, and what we see is 1 plus n minus 1 is n, divided by n is nothing different than 1. So this expression here is 1, and we are done getting 2. Now we want to further simplify this expression. And what we do is we can replace the probability that the strongest bidder has cost smaller than x by 1 minus the probability that all suppliers have costs larger than x. And of course, what we also use at this point is that we have a uniform distribution between 0 and 1. What we can do next is we again split this integral in two parts, basically in these two parts. And what we can do then is we take the integral from 0 to 1 of 1, which is nothing different than 1. So that's how we get here. And we take the integral of 1 minus x to the power of n, what is nothing else than 1 minus x to the power of n plus 1 divided by n plus 1. So finally, in the next step, what we do is we need to plug in. We have 1 minus n minus 1 divided by n, what is nothing else than 1 divided by n. And if we plug in the upper limit here, then this term is 0. If we plug in the lower limit, this term here is 1. And we get n minus 1 divided by n plus 1. If we combine those two terms, we have n plus 1 plus n minus 1 divided by n times n plus 1. We end up with 2 divided by n plus 1 as the expected price in a first price sealed bid auction with bidders' costs uniformly distributed between 0 and 1.